Hello, my friends of Water Labs. My name is Juan Montoya. Please have a great day. Today, what we are going to do is how to store the GPS position into a Postgres SQL database with a Raspberry Pi. So, what are we going to do is that we are going to install Postgres SQL on this Raspberry Pi, and then we are going to record the position from the GPS into the database. Okay, this actually tutorial comes from the frustration while trying to look for another tutorials in order to set up the GPS, because somehow the operating system has changed and the tutorials are not up to date to the and I think that the tutorials are not today about how Linux is working right now. Okay, so far we have this. We have installed Raspbian Buster in this Raspberry Pi 3, and we have enabled the SSH. Okay, so here on PuTTY, with the if config, we get the internal IP that for this case is 192.168.1.2. Okay, this is the internal IP of this Raspberry Pi. Okay, great. So here I connect to this one. I set my password, and now I am inside my Raspberry Pi. The first thing that I'm going to do is that I'm going to enable the UART. How is this? By default, the UART is disabled, so I have to enable. Okay, so I say sudo raspi config. Okay, and I'm going to interfacing options. Okay, here, and I'm going to serial, and I say, would you like the login shell to be accessible over serial? No. Would you like the serial port to be hardware to be enabled? Yes. And say serial login shell is disabled, serial interface is enabled. This is configuration that you need, and then you just go to finish, and that's it. Okay, great. So if you have done this, you can actually see what the GPS module is bringing to the Raspberry Pi. How can we see it? Cat def serial 0, and this is the information from there are many keywords here, and this is a protocol that is called NMEA, that NMEA, yeah, and this protocol is kind of, if you see, there are several keys here. Okay, you know, I have already done it, but for you, because I have done the Raspberry config before, for you it will ask you to reboot. Okay, because you have changed it, it will ask you to reboot. So if the Raspberry config do not tell you to reboot, just type this sudo reboot. Yeah, because this is in order to accept this big. Since I have done this before, actually it doesn't ask me that, but for you it should ask you to reboot. Okay, once again I do the login IP at 198.168.1.2. Great. So we can check the result, which we can check the readings from the GPS serial 0. Okay, Control Z. Okay, great. So right now what we are going to do is we are going to install some software. Remember that all the I cannot make this bigger like this bigger. Let me check if I can make it bigger. Okay, yeah. Okay, great. Yeah, and I hope it's more clear to you. Let me check another one. Yeah, this one should work. Okay. Okay, so what is next? What I'm going to do is to install. I'm going to sudo apt get update. Okay, just to update my Debian Buster, Raspbian Buster, Debian Buster. Okay. Okay, and then I'm going to install Postgres. Sudo apt install Postgresql. Postgresql. Okay, yes. Okay. Explain now. Okay. Mm-hmm. Okay. Next to this, we are going to check if the Postgres is running on our computer. So I say type clear and then say sudo service PostgreSQL status. Okay, it's working. Great. So, and then I create a super user. So it's necessary. Well, I am not so deep into databases. It should be not necessary, but at least for this tutorial is necessary to create a super user. So I say sudo postgres create user super user p. Okay, sudo postgres create user super user p. Okay, that's it. You get the super user, and then we are going to say create user interactive score p. Okay, and say Hatari, and the password will be labs. This is important because when we run the Python script to get a position, actually it's linked to the user and the password. Shall the new role of super user? Yes. Great. And then we are going to create a database. Create db Hatari EPS position. Okay, great. So with that, okay, I have already created a database, and now I'm going to create a table in the database. So PSQL EPS position Hatari, and then I have to insert localhost, otherwise it doesn't run. Okay, user and my password labs. Great. So right now I am inside the PSQL, and then I can list. There are some commands. For example, with this I can list all the tables. Control Z. Yeah. Oh, sorry. Well, once again, labs. And then what else I can do? I can change to the table. I will quit, clear, and then I will enter again. Okay, labs. I can change to the table /c EPS position. Okay, with that I enter I use the databases like use database. Okay, EPS position. I'm now connected to EPS position, and I say create table date court where the ID will be the serial primary key, where the string will be numeric, the ordering will be numeric, the elevation will be numeric, and the date will be timestamp. Okay, close parentheses and semicolon. Okay, I have already created the table, and then I can do describe, and this is the description of the table, where it shows all the columns that I have already defined. Okay, Ctrl C, don't know why. Control Z. Okay, well, if I don't know why it has changed the output here, but if you want to exit from the PSQL, you have to type \q. Okay, right now I'm going to install some libraries. So SQL Alchemy. Okay. Then I'm going to install PSI cop G2. And then the third one, the first one is a really powerful library that deals with most of the databases. The second one is the driver for the PostgreSQL clear. And then the third one is a parser of the data from the GPS. And this one is pip3 install pynmea2. Okay, pynmea2. nmea2. Okay, great. So okay, on the description of this video you are going to find a script of the Python script that actually read the GPS and read the GPS and add this to the data, to the Postgres, to the read the GPS and add to the database. Okay, right now, so you don't have to type it, so say sudo nano GPS position.py. okay, and here I have the okay, first Control C, Control V. Okay, here, so it's a, I don't know why it doesn't break. Okay, from pynmea, from datetime, import datetime. You have to get rid of this, otherwise actually they won't work. So you have to get rid of these green squares. Okay, create engine, from SQL Alchemy, import the creative base, session maker. Okay, great. Next, we are going to connect to the database. Okay, so this is the command that actually, this is the user and the password, and the database is engine. Actually this is duplicated, so you don't need it. It's a declarative base, session maker, and we have to get rid of these green rectangles. Okay, then we are going to create the model, the data model. So this is the model of the data that will be inserted to the database. Okay, great. So this is on the database. Okay, so oops, yeah. So this is this one opens the serial. And the next ones will, while true, no, those 1 2 3 4, try 1 2 3 4, line if one two three four. One two three. So it has to be, each indentation is four spaces. Okay, great. So this print, yep, GPS time, GPS read, in date. Oh, this one is only one line. Okay. Okay, and then we have to handle the exceptions. Control C. Okay, except Control X and yes. Okay, so that's it. So if you run Python 3 GPS position, actually it will read the GPS, and from the GPS it will provide you, it will print the coordinates, and it will store on the database. So these are the coordinates. Okay, so we are going to break this, and then we are going to show you PSQL EPS position. Okay, so we are going to see if the database actually has the data. So labs, and then say show from date codes. No, sorry, it's not show, it's select from date codes. Okay, and semicolon, and these are the, if you see, these are the values that were stored by that are the values on the database that come from the GPS position and the date. Okay, there is something in the code. For example, there is one. I use the UK time. Okay, and there is 1 hour of difference in between the GPS time and the UK time. Yeah. So, for example, I will quit from this. Clear date. So right now is 16 hours 26. Okay, and if I show you the script, actually you see here I use a time delta here, and this time delta, I don't know if, oops, sorry. Wow, my face is actually, okay. So if you see here, there is a time delta. Okay, where is the time delta? Actually, you cannot see my cursor. Well, on GPS read, I use a time delta. This time delta can help you in order if you are using your local time, and then you have to change from the GPS, because actually the hour from the GPS is independent from the time. So you have to put on your, or you have to do your own calculations about how to transform the GPS time into your local time. Okay, that is if you use your local time. Okay, great. So clear, yeah. Then what else? I'm going to make this GPS position. Okay, I made a mistake. On the documentation, I have to make a dir, let's say GPS scripts. Okay, these are GPS scripts, and then I'm going to move GPS position to GPS scripts, because all the commands that are on this tutorial are actually described on the documentation, and following the documentation you have to create this GPS position under GPS scripts. And then if we change to GPS position to GPS script, and then we type there, GPS position appears there. Okay, then we are going to make this script executable chmod plus x GPS position, and then I'm going to run no hub to run this on the background, because actually I want this process to run on the background forever, and each second it will store the position. So home by GPS scripts, GPS position, and then the output in case of any this is in case of any this is in case of any error that we might have. So we run it, and then if something went wrong, if we type ls and then if we say cal output.log and say okay, yeah, we have a problem here, and it say okay, so I say nano GPS, something went wrong here. Okay, what it could be? Okay, Control X, yes. Cut output.log. Okay, well, maybe the thing that went wrong, it was because actually this line was not the first one. The red line that you see here. Okay, then what else? Okay, so let's see if the GPS position is running. So say px ax grep GPS position, and then we see that here is running with Python 3. This process is running. Okay, and then once again clear, I can call and I will print the date, and then I can call the command this one, type my labs, and then say show select from date chords. Semicolon, and then if you see 31, 31, 32, okay, if we compare with the date, yeah, once again date, once again clear date, so right now I'm 1632, so you say if we go to the database labs, select from date chords, it actually goes to say 1632 with 1633 with one record per second. Okay, so this is a tutorial. If you want this to run from the beginning, you can put this no hub. No, actually, if you want this to run, you have to insert this on your Chrome. Okay, and well, we are going to, this is actually on our conception a worker, because we want that the Raspberry will be stored in the position, and then we are going to store image with the time, and then we are correlated with the image with the time with the position. Okay, so that was all for me in this tutorial. Hope that you find it interesting. If there was some technical problems, really sorry for that. All the commands will be on the description of the video and the scripts as well, and hope to see you in coming tutorials. Bye bye.